Good day. Welcome to another series of Chemistry Just Got Easier with the Outrutters. In this class, we are still on balancing chemical equations because we have to take more examples in order to get a mastery of the topic. Let's see what we have on the board. Write a balanced equation for the combustion of ammonia in air. Let's see what we have. Ammonia. Now, we have one ammonia is bond in air. You have NO and H2O. And as we can see, this real equation is got balance. So let's try to see the number of atoms we have on the left side and the number of atoms we have on the right side. So we have NHO, NHO. Now on the left side, we have just one atom of ammonia, one atom of nitrogen, and we have just one mole of ammonia. So one atom of nitrogen. On the right side, we have one atom of nitrogen. On the left side, we have 3 atoms of hydrogen. And on the right side, we have 2 atoms of hydrogen. On the left side, we have 2 atoms of oxygen. On the right side, we have 2 atoms of oxygen. So looking at this equation, nitrogen is balanced, hydrogen is not balanced, oxygen is also balanced. So if nitrogen is balanced, hydrogen is not balanced, and oxygen seems balanced. Let's try to balance hydrogen. So we have 3 here, we have 2 here. How can we make them equal? Let's just multiply them with each other. So here I will say everywhere I have hydrogen here, I will say times 2. Anywhere I have hydrogen here, times 3. So interchanging it. So I have hydrogen here. It will be, remember, when you want to balance, don't change the subscript, you change the what coefficient. That is 2 multiplied by NH3 plus O2 to give NO plus 3H2O. Now let's try to do a quick atom check. Now nitrogen here, 2 times 1 atom of nitrogen gives 2. 2 times 3 atoms of hydrogen gives 6. Now let's see for oxygen. Oxygen remains 2. Now let's see. Now nitrogen is still 1, meaning nitrogen is no longer balanced. Then hydrogen 3 times 2, which is 6. And oxygen is, here you have 1 plus, 3 plus 1, which is 3 times 1 rather, which is 3. So your hydrogen is 4. So let's see. Nitrogen is 2, nitrogen is 1. Oxygen is 6, hydrogen is 6. Oxygen is 2, and oxygen here is 4. So what we simply do is we try to balance the number of nitrogen and oxygen. And how do we do that? How do we make this? Remember, one more thing is try to balance every other atoms first before oxygen. So I have 2 nitrogen here, I have 1 nitrogen here. So this is 2, this is 1. I can just interchange it, multiply by 1, multiply by 2. So let's see what we have. So here 2 times 3, that will be 2NH3 plus O2 to give, now this is multiplied by 2 here. 1 times 2. Remember, why am I pushing this 2 here? Simply because the position of nitrogen is in this place, and you use the 2 as a coefficient. Plus 3H2O. Now let's try to do a quick atom check. Nitrogen here is 2, hydrogen here is 6, oxygen here is 2, nitrogen, which is 2 times 1, 2, Oxygen 2 times 1. Oh, not oxygen yet. Hydrogen 3 times 2, 6. Oxygen 2 times 1, 2 plus 3 times 1, 3, which is 5. Now we're in a dilemma. Oxygen here is 2 and oxygen here is 5. So nitrogen is balanced on both sides of the equation. Hydrogen is balanced on both sides of the equation, but oxygen is not balanced. We have 2, we have 5. How do we get them equal? Anywhere we have oxygen in the reactants, we multiply by 5, this. And anywhere we have oxygen in the product, we multiply by 2. Okay, this gives 2 plus 3, which is equals to 5 times 2. 2 plus 3, 5. And remember, we want to multiply by 2, this 2, to make it equal. Because when you multiply 2 by 5, becomes 10. When you multiply 5 by 2, it becomes 10. But remember, anywhere you have oxygen in the product, you multiply by 2. So we have ammonia, 2NH3, plus O2. You see multiply by 5, 5O2, to give. Now, we have oxygen here. We already have 2NO. I will still say anywhere you have oxygen in the product, you multiply by 2. So I'm simply going to say 2 times 2NO plus. Now we have oxygen in 3H2O. So I'm going to say, oh, this is quite. Okay, let me just rewrite everything. Okay, let's take it again. Now we have 2NH3 plus. Now 5 times 2, we have oxygen here. That is going to be 5O2 gas. Now why am I writing 5 here? Because the coefficient of oxygen here is 1. That's why I'm simply saying like 5 times the coefficient, which is 1. But when you say times number of atoms, which is 2, 5 times 2 gives 10 oxygen atoms. So here we have oxygen here. And I said anywhere you have oxygen in the product, multiply by 2. That is 2 times 2NO gas plus. We also have oxygen here. So multiply that one by 2. Why am I adding this? 2 times 3H2O. So here we have, now coming down, 2NH3. 2NH3. So I'm going to rewrite this. 2NH3 plus 5O2 gas. Then 2 times 2. Remember there is a coefficient here. When you multiply this 2 by this coefficient, it becomes 4NO plus 2 times 3. When you multiply 2 by this coefficient that is already here, you have 6H2O. Now let's do a quick atom check. Nitrogen here is 2. Nitrogen here is 4. Wow, what we balance before is no longer balanced. Hydrogen here is 6. Hydrogen here is 12. Wow. And oxygen here, 5 times 2, which is 10. Oxygen here, 4 times 1, 4, plus 6 times 1, 6. Now, oxygen is balanced, and we are left with nitrogen and hydrogen. So let's see nitrogen. Here is 2, here is 4. How do we make 2 equals to 4? Now you are not going to interchange, because the first thing that you can get that will make 2 equals to 4. You can actually say 2 times 2 is equal to 4, and 4 times 1 equals to 4. But I'm interchanging there because in these two numbers, you cannot say 2 times anything. You can only say 2 times 2.5 will give you 5. Or for 2 times 2.5 will give you 5, which is this. So, and we don't want a denominator. That is why I interchange it here. So yeah, 2 and 4. How can I make 2 equals to 4? I can simply say times 2. Mean anywhere I have hydrogen here, I'm going to multiply it by 2. Now, and here we have, let's see. Okay, let's write 2. So 2 times, remember the coefficient is 2NH3 plus 5O2 to give 4NO plus 6H2O. Now let's do a quick atom check. 2 times 2. This is 4NH3 plus 5O2 to give 4NO gas plus 6H2O. Now let's see. Nitrogen is equals to 4. Hydrogen here, 4 times 3 is 12. And then oxygen here is equals to 10. Are we good? So let's see. Here we have 4 times 1, A is equals to 4. 4 times, let's first see for hydrogen, 6 times 2, that is oxygen is hydrogen is equals to 12. Then oxygen, 4 times 1, that is 4. 6 times 1 here, which is 6. So let's see. In the reactants, we have 4 atoms of nitrogen. In the products, we have 4 atoms of nitrogen. In the reactants, we have 4 atoms of hydrogen. In the reactants, we have 4 atoms of nitrogen. In the reactants, we have 4 atoms of nitrogen. In the reactants, we have 12 atoms of hydrogen. In the reactants, in the products, we have 12 atoms of hydrogen. In the reactants, we have 10 atoms of oxygen, and in the reactants, we have 10 atoms of oxygen. So, here when we try to balance nitrogen, and luckily for us, as we try to balance nitrogen here, our oxygen became balanced, our hydrogen rather, became balanced at the end of the day. Because here you have nitrogen and you have hydrogen. And you can see that our reaction, our balanced equation, obey the law of conservation of mass, because the number of atoms on the reactant is equal to the number of atoms on the product. Thank you for listening. Book the tutors for your personalized online chemistry, mathematics, and biology classes at an affordable price. Follow the tutors for daily chemistry and mathematics content. Follow, like, and share. Bye. See you next time.